Alright, so today we want to talk about x and y intercepts. So far we've talked about relations and functions and different ways that we can represent a relation and a function. So we talked about graphs, tables, ordered pairs, all the equations, statements, all the things. So if there is a point where the graph of a function crosses the x-axis, that is the x-intercept. So the x-intercept crosses or intersects the x-axis. It's always in the form x0. So the y value, f of x, is always 0. So when we to find an x-intercept, replace the y with 0. And that'll tell you where it crosses the x-axis. Similarly, where the graph crosses the y-axis is called the y-intercept, and it's in the form 0y, where the x is 0. So to find the y-intercept, replace the x with 0 and solve. So let's look. For this first, it says determine the x-intercept. So to find the x-intercept, we say that y equals 0. So f of x is 0. So first, replace f of x with 0, and then solve for x. So when we solve, we add 12. That's 12 equals 3x. So 3 times x to get rid of the 3. Divide both sides. 4 equals x. So what that means is if we have a graph, it's going to cross the x-axis at 4, 0. So, that's what I mean. On a coordinate plane, this is our x-axis, and this is our y. So the x-intercept, it means this line would cross here. And so our line would end up looking, it would be like, well, that's not very good. But our line is going to look something like that. But we're not going to draw it yet, because the next part is to determine the y-intercept. So for the y-intercept, we replace the x with 0. And we solve. So 3 times 0 is 0. Minus 12 is negative 12. So this right here is my y-intercept. So I'd go 2, 3, 4, 5, 6, 7, 8. So it's actually going to be much steeper than that. So this would be our line. And if you graphed the 3x minus 12 in Desmos, you would see that. So here, determine the x-intercept of this graph. So for the x-intercept, that means replace the g of x with 0. So this is going to be 0 equals the square root of x plus 3. And then we solve. So to get rid of a square root, the opposite of taking a square root is squaring. So 0 squared is 0, and that leaves me with x plus 3 we solve and we get x equals -3. Determine the y-intercept. So for the y-intercept, we replace x with 0. So what that means is we're solving for the y. We're solving for the y. So that's going to be the square root of 3. And you can do the square root of 3. I'm gonna so that is 1.73. Approximately, because it's an irrational number, but so you would round it. And so what this looks like, you can graph it in a calculator, but if I pull up my calculator, it'll stop recording. So I'm not going to do that. So that tells me my x-intercept is -3, and my y-intercept is not quite at 2, and this actually goes kind of like this. If you graph this right here in Desmos or graphing calculator, you'll see. Alright, so now this next one, determine the x-intercept. So that means 0 equals the square root of x minus 3. And if you remember, we said when we're taking the square root, the opposite of square root is to square. So that leaves us with 0 equals x minus 3. The goal is to solve for x. 3 equals x. So 3, 0 is our x-intercept. So what that means is on a coordinate plane, that's where the x-intercept would be. And then it says show that there is no y-intercept. So it's telling us there's not going to be a y-intercept, but let's see why. So what that means is if I say 0 minus 3, I get the square root of -3. Now, why can I not do that? Think about it. The square root of a negative would be an imaginary number. So this means there is no y-intercept. This graph, if you looked at it, it would look like this, and you would see that it's never going to have a y-intercept. Okay, so now this. Determine the x-intercept. To find the x-intercept, you replace the y with 0. Now, this is a quadratic function, so I cannot just, solve it. I have to either factor and solve or use the quadratic formula. So to check to see if I can factor, I ask, are there 2 factors of -15 that add up to -2? So the first thing that I think of is -5 times 3. So that tells me x squared minus 5x plus 3x minus 15 gives me this, which gives me x plus 3 as a factor and x minus 5 as a factor. And so when I was looking at this, I grouped the first 2 and the last 2, and then I looked and said, well, what was the GCF here? X. Factored it out. Then I said, what's the GCF? 3. So the x plus 3 is one of my factors, and then the x minus 5 is the other. So if factoring is something you don't remember, then that is something you'll want to review. So x plus 3 equals 0. When x is negative 3, x minus 5 is 0 when x equals 5. So in this case, I have two x-intercepts, negative 3, 0, and 5, 0. So when you have a quadratic, you might have two x-intercepts. Now, the y-intercept. We say, okay, well, f of x is equal to 0 squared minus 2 times 0 minus 15. Because finding an x-intercept means finding a y-intercept means you replace your x's with 0. And then that gives me, when I do the math here, I get negative 15. So my y-intercept is 0, negative 15. So I'd have my two x-intercepts, and my y-intercept is going to be 12, 13, 14, 15. So, kind of like this. Not the best drawer. If you put it in a calculator, you'll see a better looking graph. So now this next one. So I can determine the x-intercept. So I can see I either can use the quadratic formula to find my x-intercepts, or I can factor. So if I factor, I would say 2 times 3 is 6. I need two numbers that multiply to 6 and up to 7. So that would be 6 and 1. So that is 2x squared plus 6x plus 1x plus 7. Now, when we factor, we group the first two and the last two. So in factoring, we look and ask ourselves, well, what's the GCF here? Well, I can divide out the 2x, and that leaves me with x plus 3. Then looking here, the GCF is just going to be 1. Ooh, well, that didn't work because I didn't write it right. This was supposed to be a 3 on the end. I was like, sorry guys. So now, one way I know I made a mistake is that should be the same, that x plus 3. And then our other factor comes from the GCF part, so 2x plus 1. So we need to say 2x plus 1 equals 0, and x plus 3 equals 0. Well, x plus 3 is 0 when x is negative 3. For the other one, I know it's negative 1/2, but if you can't just look at that and tell, you would subtract 1, then divide by 2, and x equals negative 1/2. So those are our two x-intercepts. It doesn't determine the y-intercept. I'm going to do it on the same page here. So the y-intercept, to find the y-intercept, we would just replace the x's with 0. And when you do the math here, you get 3. So your y-intercept would be 0, 3. Your x-intercepts were negative 1/2, 0, and negative 3, 0. What you want to make sure you don't do is you want to make sure you don't try to put the -1/2 and -3 in an ordered pair together, because that is wrong, but I see it happen. So now if I was graphing this, like sketching the graph, the 0, 3 is going to be up here. The -1/2 is going to be about here. The -3 now I kind of want to look at this and make sure. What was it? 2x squared plus 7x. Yeah, okay, this is right. Oh, that wasn't very good. It should go through the points. It's decent. All right, so now sometimes the factor may not work and you'd have to use the quadratic formula. So I'm going to make a note of that. Sometimes you might not be able to factor. So sometimes you may have to use the quadratic formula. The quadratic formula. And so when that's the case, you would want to write the formula down, choose each one of your ABCs. So if you were in Math 100 with me last semester, we did the quadratic formula right at the end. But if not, you might remember it as the -b plus or minus the square root of b squared minus 4ac divided by 2a. So in that last problem where we had 2x squared plus 7x plus 3, a would have been 2, b 7, and c 3. So if you had done this using the quadratic formula, you would have said -7 plus or minus the square root of 7 squared minus 4 times 2 times 3 divided by 2 times 2. So -7 plus or minus 49 minus 24, 49, 36. Nope. Hold on. What was I saying? So 49. Oh, my thing messed up. 49. 24. Yeah, it's 25. I knew it was a perfect. My thing keeps disconnecting. Alright, so 25. So that's a -7 plus or minus 5 over 4, which means you would do -7 plus 5, which is -2 over 4. And you would do -7 minus 5, which would be -12 over 4, which equals -1/2, and -3, which is what we had gotten for our x's up here as well. So this is applying the quadratic formula. We did the b already. up there. So we have seen that a function could have one x-intercept or two x-intercepts. Can it have 3 or 4 x-intercepts? Yes, because it could have a function, for instance, this right here would be a function, but we would have we would have 3 x-intercepts. Can you think of a function that has no x-intercepts? So a function that has no x-intercepts, this right here could have no x-intercepts. So no x-intercepts could be horizontal line. They have y-intercepts. So now, can a function have more than one y-intercept? So, if it has more than one y-intercept, that would make it not a function because you would have 2 points when you do the vertical line test. No, that would be 2 points failing the vertical line test. Okay. Can a function have no y-intercept? Alright. Can a function have no... I made that line. That was kind of ridiculously long. Can a function have no y-intercept? So, think about it. A function could have no y-intercept if it never crosses the y-axis. And we saw that actually already. Let's say here, this function right here has no y-intercept. So, can a function have no y-intercept? Yes. Think about this right here, no y-intercept. You also you could have logarithmic functions. I can show you some more when we're in class, but if I pull up the online calculator, it'll kick me off of the video. But what I want you to really get from this is that x-intercept cross x-axis plug 0 for y. For your y-intercept, cross the y-axis, plug 0 for x. Alright, so I will get this uploaded. And then I do have an assignment for you all to work on.